Simplification of CFG. Simplification of CFG consists of elimination of null production, elimination of unit productions, and the elimination of useless symbols and productions. So first one, elimination of null production is needed to ensure that the length of the intermediate strings in the derivation to be shorter than the final string. So if you have a string in between the derivation which consists of some null variables which derive the null string, then the length of that string is more than the length of the final string, so which you don't want to happen. So you have to eliminate the null production. Second is the unit production. So a unit production is one where the left hand side of the production and the right hand side of the production consists of a single variable. So like A derives B, capital A derives capital B. So where B is just replacing the variable A. Then if again B is a unit production, suppose B derives C, then it is just replacing B by C. So instead of that, I could have replaced A by C itself. So this is a need is the number of steps in the derivation tree are not much more than the length of the final string. If you just have the unit production, it just increases the length of the derivation tree. It is unnecessary. Next is the elimination of useless symbols and productions. The need is that we would like to have a compact grammar with fewest possible variables. Unnecessary variables we can remove by using the elimination of useless symbols and productions. So we'll see the one by one. First is the elimination of null productions. Nullable variable is one where you have the production of the form A derives epsilon, or there is a derivation which starts at A and finally ends up with epsilon. So you have a context-free grammar where the left hand side is a single variable, and on the RHS, if you are using some set of productions, if you can generate epsilon, then we say that A is a nullable variable. Next, the procedure for removal of such nullable variable is here. If G is equal to VTPS, then G dash is obtained by changing the productions, where P dash contains all the productions for each of the production. A derives x1, x2, xk in G, where assuming that A is a nullable variable, then add A derives alpha 1, alpha 2, alpha k, where alpha I is equal to xi if xi is not nullable variable, and it is equal to xi or epsilon if xi is a nullable variable. And not all alpha i's are epsilon. That means if you replace all the alpha i's by epsilon, you should not get, if you replace all xi's, you should not generate epsilon, which is again a null production. So this you have to repeat for each of the production. That is by replacing zero nullable variable, one nullable variable, multiple nullable variables unless you retain something on the RHS. That is the procedure. So let us see one example. So first example, eliminate the nullable variables from the following CFG. So these are the set of productions. So you can observe directly A derives epsilon. So A is a nullable variable. B also derives epsilon. So B is also a nullable variable. And since both A and B are nullable variables, and S will also derive nullable variable, null production. So yes, A, B are the set of nullable variables. Now, how do we write the changed, that is the modified productions are? First, we retain the productions as it is, and now we have to identify which are the nullable variables. So both are nullable variables. You replace one nullable variable at a time. So B, if you replace by epsilon, so you'll be getting A. If you replace A by epsilon, you'll be getting B. And you should see here, if you replace both of these, you will be getting epsilon, so that you should not write. Next is A derives A. So you are removing this, you are left out with this. So again here you have two nullable variables. So first we have to retain as it is everything, then replace one nullable variable at a time. So you will be getting AA and AA. So if you replace both the nullable variables here, you can observe you are left out with single A, which has to be written. Here you can observe if you replace both, you will get epsilon, so that you should not write. But here if you replace both, you will be left out with A, that you should write. So likewise for B derives BBB, you write the production as it is and replace one nullable variable at a time. So you'll be getting BB, and replacing both you'll be left out with B. So this is the productions which are obtained after removal of the null productions. So example 2. So these are the productions given. So B derives epsilon, therefore B belongs to the set of nullable variables. C derives epsilon, so C also belongs to the nullable variable. And you have to make sure that if B and C are on the RHS alone, then the left hand side will also be a nullable variable. So A will also be a nullable variable. So the set of nullable variables will be A, B, C. And now retain all the productions except the null productions, and A, B, C are the nullable variables. So you have retained the production as it is, that is by removal of 0 nullable variables. Next, removal of 1 nullable variable. So what I will get here is, suppose here, so this is obtained by replacing A by epsilon. So you'll be getting BCA. So now this will be obtained by replacing B by epsilon. This is obtained by replacing C by epsilon. And these are the three productions which are obtained by replacing one nullable variable. Next, you can see here. So you are replacing two nullable variables at a time. So you'll be getting CA. Then if you replace BC, you'll be getting AA. If you replace A and C by null, so you'll be getting BA. So these are the three productions you obtain by replacing two nullable variables at a time. Next, all the three nullable variables, if you remove, you are left out with A. That also I have written. Next is another production of S. You have BD, and D is not a nullable variable, so you just write BD as it is. Next is A derives BC or B, so that you write first. These two you write first, then remove one at a time. So see, if you are removing by substituting epsilon, you will be left out with B, and if you substitute C by B by epsilon, you will be left out with C. So if you replace both, you will get epsilon, that you should not write. Next is B derives B and C derives C. You should eliminate these productions, and D derives D. So we'll stop here and we'll continue with the elimination of unit productions in the next video. Thank you.